Hello students, welcome back to my YouTube channel. In this video, I am going to solve problem from the question paper April 2026, part of previous year question paper series for the subject Allied Mathematics 2. The problem is from part B, 4-year series. Problem number is 15th one. It is given as if f of x equal to set of all minus pi in the interval minus pi less than x less than 0, same f of x value is x in the interval 0 less than x less than pi, then we have to prove that f of x equal to minus pi by 4 minus of 2 by pi into cos x by 1 square plus cos 3x by 3 square plus cos 5x by 5 square plus 3 sin x by 1 minus sin 2x by 2 plus 3 sin 3x by 3 minus dot dot dot. Simply we have to find Fourier series f of x, where f of x is as having two values. One is minus pi, another one is x. Minus pi in the region minus pi less than x less than 0, x in the interval 0 less than x less than pi. Solution. First write the Fourier series formula, that is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx plus b n sin nx. First find a naught. A naught is 1 by pi. See here minus pi to plus pi. Therefore, our integral value minus pi to pi f of x dx, which is equal to 1 by pi. Here we have two values for f of x, minus pi in the interval minus pi less than x less than 0, x 0 less than x less than pi. Therefore, I am going to write this minus pi to pi as minus pi to 0 plus integral 0 to pi f of x dx. Here f of x dx. We have one result. Integral a to c f of x dx can be written as integral a to b f of x dx plus integral b to c f of x dx. I am using this result for this problem. Now 1 by pi integral minus pi to 0, the value is minus pi. Minus pi dx plus integral 0 to pi, the value is x. One by pi, take minus pi outside, integration of dx x minus pi to 0 plus 1 by pi common plus x squared by 2 limit 0 to pi. 1 by pi minus pi 0 minus of minus pi for the first one plus 1 by 2 pi square minus 0, upper limit minus lower limit. 1 by pi minus pi into pi plus pi square by 2. 1 by pi minus pi square plus pi square by 2. Simplification 1 by pi minus 2 pi square plus pi square by 2, simplification, minus of pi square by 2 pi, simplification, minus pi by 2. See, a naught is minus pi by 2. I need a naught by 2 minus pi by 2 into 1 by 2. A naught is minus pi by 4. This is value for a naught by 2. Now I am going to find an. From we have to find an means the formula 1 by pi integral minus pi to pi f of x cos nx dx. 1 by pi, again I am going to use the same formula, minus pi to 0 f of x cos nx dx plus integral 0 to pi f of x cos nx dx. For this part f of x is minus pi, for this part f of x is x. Is it correct? Yes. Now substitute 1 by pi integral minus pi to 0 minus pi cos nx dx. Second integral 1 by pi. I am multiplying 1 by pi with two integral values. Integral 0 to pi x cos nx dx. I am going to take this integral as I1, this one as I2. For an, I am going to find separately In, then I2, so that it will be easy. What is I1? Minus pi by pi integral minus pi to 0 cos nx dx minus integration of cos nx sin nx by n minus pi to 0 minus of sin 0 upper limit sin of minus n pi minus sin n pi, again sin n pi minus of sin 0 is 0, sin n pi is 0, value is 0. For I1 the value is 0. Now I am going to find I2. What is I2? 1 by pi integral 0 to pi x cos nx. Here I am going to use integration by parts by taking u as x, integral dv, integral cos nx dx, find du by dx, value is 1. What is du? dx. Integration of dv, v, integration of cos nx, sin nx by n, uv minus integral v du, 1 by pi x sin nx by n with limit 0 to pi minus integration 0 to pi. What is v? Sin nx by n into du dx. Here I am applying uv minus integral v du. This is nothing but integration by parts. 1 by n pi upper limit pi sin n pi, lower limit 0. minus of 1 by n pi integration of sin nx minus of cos nx by n with limit 0 to pi. This part 0 because sin n pi is 0, this part already 0, remaining term minus 1 by n pi minus of minus plus n into n square, remaining upper limit cos n pi, lower limit 0, cos n pi minus 0, the value is minus 1 power n minus cos 0 is 1 divided by n square pi. See, an has two values. If n is even, minus 1 square minus 1, 1 minus 1, 0 when n is even. If n is odd, minus 1 power 3 minus 1, minus 1 power 3 minus 1 minus 1 minus 2. Minus 2 by n square pi if n is odd. Very important for both the cases, n is even and n is odd. Now I am going to find Bn. What is Bn formula? 1 by pi integration minus pi to pi f of x sin nx dx. 1 by pi, again I am splitting the integral minus pi to 0, f of x sin nx dx plus 1 by pi integral 0 to pi f of x sin nx dx. The value for f of x minus pi to 0 minus pi, for this one x. Therefore 1 by pi integral minus pi to 0 minus pi sin nx dx plus 1 by pi integral 0 to pi x sin nx dx. Again I am going to take this one as I1, this one as I2. For Bn, separately we have to find integral value minus pi by pi integral minus pi to 0 sin nx dx. Both will get cancelled, pi remaining minus of integration of sin nx minus of cos nx by n, limit minus pi to 0, 1 by n minus of minus plus cos 0 minus of cos of minus n pi cos n pi 1 by n, 1 minus minus 1 power n, because cos 0 is 1, cos n pi is minus 1 whole power n. Answer is 1 minus minus 1 power n divided by n. Here also Bn, two cases. If n is odd, 2 by n. If n is odd, if n is even, 0. n is odd means minus 1 power 3, 1 minus of minus 1 power 3 plus 1, that is 2 by n. If n is even, minus of minus 1 square, 1 minus 1, 0. Very very important. We have Bn two values, n is odd 2 by n is even 0. This is for I1. Now I2. I2 1 by pi integral 0 to pi x sin nx dx. Again, by method of integration by parts, take u as x, du by dx 1. What is du dx? Integral dv integral sin nx dx. What is v? Minus of cos nx by n, uv minus integral v du. uv ux v minus cos nx by n minus cos nx by n for Bn 1 by pi uv minus integral v du minus x cos nx by n limit 0 to pi minus of integral 0 to pi v du. This is v du, this is uv, minus of minus plus, take n outside, it becomes 1 by n, integration of cos nx sin nx by n limit 0 to pi. Here upper limit is pi, therefore minus pi cos n pi by n, lower limit is 0, minus of minus plus 0 because upper minus lower. Therefore, if you substitute the limit, upper limit sin n pi, lower limit 0, upper minus lower 0 minus 0. For this part, minus pi cos n pi is minus 1 power n, yes, minus pi minus 1 power n by n. Now simplify, minus of minus 1 power n, it becomes minus 1 power n plus 1 divided by n pi. Both these terms will get cancelled. This is Bn. For Bn, this is I2. This is I2 for Bn. Now Bn, what is I1? I1, if n is odd, 2 by n. We have two values. 2 by n if n is odd, 0 if n is even. This is for I1 plus I2. I2 is minus 1 power n plus 1 by n. This is value for Bn. Now substitute all the value in f of x, that is equal to a naught by 2 summation n equal to 1 to infinity a n cos nx plus b n sin nx. You mark that equation as 1 so that it will be very easy. This is equation 1. Substitute all the value is in 1. What is a naught by 2? What is a n? We have now found out bn. This is bn. What is a naught by 2? We find initially a naught by 2 minus pi by 4. A naught by 2 minus pi by 4. What is an? This is two cases. 0, n is even, minus 2 by n square pi. Minus 2 by n square pi if n is odd. 0 if n is even. This is an, this is a naught by 2, this is bn. Okay. Now substitute all these things in 1. 1 implies f of x a naught by 2 minus pi by 4 plus summation. See, in an, if n is even, 0. Only for n is odd we have the value minus 2 by n square pi. Therefore write n equal to 1 comma 3 dot dot dot. Because summation consists of both even and odd. I am writing only odd because if for n is even case, an is 0. An value minus 2 by n square pi cos nx. This is an. Now for bn, summation. Here also n is even, the value is 0. I am going to write only for odd case. N equal to 1 comma 3. What is bn? 2 by n plus minus of 1 power n plus 1 by n. These two terms I am going to add because this is I1, this is I2 into sin nx. Now I am going to give values for n equal to odd case. Minus pi by 4, take minus outside. Odd case means minus 2 by 1 square pi cos x minus 2 by 3 square pi cos 3x minus 2 by 5 square pi cos 5x minus dot dot dot. This is for second term. For the last term, give values for n equal to 1. 2 by 1 plus minus 1 power 1 plus 1 by 1 sin x. Plus 2 by 2 plus minus 1 power 2 plus 1 divided by 2 sin 2x plus 2 by 3 minus 1 power 3, sorry, only for odd case, no. Okay. I am giving values n equal to 1. Is it okay? Yes. N equal to 3. One square pi, 3 square by 5 square pi. All these things an. This one a naught plus, see, bn is having two values. N is odd 2 by n is even 0. This is for common. because of I2. I am going to write, for odd case I will combine these two. For even case, if you combine, only this term will be used for applying n equal to 2, 4. Okay. Therefore, for odd case, I will add 2 by n with minus 1 power n plus 1 by n. For even case, if you add 0 plus minus 1 power n plus 1 by n, simply minus 1 power n plus 1 by n. Okay. Substitute n equal to not 1 here. I will write here n equal to 1 comma 3, but here n equal to 1 comma 2 comma 3 dot. Now everything correct. Put n equal to 1. 2 by 1 plus minus 1 whole square by 1 sin x. Okay. If n is 2 even term, this part 0 plus minus 1 power 2 plus 1 by 2 sin 2x. n equal to 3 odd term. Odd term means 2 by n, that is 2 by 3 plus minus 1 power 3 plus 1 by 3 sin 3x plus dot. This is for Bn. Now final answer minus pi by 4. See, minus 2, minus 2, minus 2. Take minus 2 outside. Also, pi is common in all the terms. Take pi outside. Minus 2 by pi. Remaining term cos x by 1 square. Cos x by 1 square plus only odd term cos 3x by 3 square plus dot. See here, minus 1 square is plus 1. 2 plus 1, 3. 3 by 1 sin x. That is 3 sin x by 1. Here, if you add 0, minus 1 power 2 plus 1, minus 3 by 2. Minus 1 power 3 minus 1 by 2. Therefore, I will write it as minus sin 2x by 2 for this term. Here, odd case 2 by 3 minus 1 power 3 plus 1 minus 1 power 4 minus 1 2 minus 1 1 by 3 2 by 3 minus 1 power 4 plus 1 minus 1 power 4 plus 1 plus 1 by 3 2 by 3 3 by 3 is 1. Answer is sin 3x. A0 by 2 minus pi by 4. I am taking minus 2 outside, also pi outside. Remaining term cos x by 1 square plus cos 3x by 3 square. For the Bn case, 3 sin x by 1 minus sin 2x by 2 plus 3 sin 3x by 3. This is formation of Fourier series for f of x. The problem was asked for 5 marks in part B from April 2026. This is part of previous year question paper series. I will solve remaining one problem in part C, again from Fourier series for 10 marks. In the upcoming video, you just subscribe my channel, share with your friend Also like my channel. Thank you.